So, find the zeros when the leading coefficient is not 1. Okay, this is where the rubber meets the road here. The leading coefficient is not 1, it's 10. So we have all the factors of 10. Here's 1, here's 2. We skipped some because they were repetitive. For instance, 4 divided by 2 is just 2, and I already have 2. Then 5. And then 10, and there's some repetitiveness with 10, so 10 is a shorter list as well. Anyway, those are the result. I have all these possibilities, my. And what goes on the top? Well, the 12 goes on the top, so factors of 12 on the top, factors of 12 on the top, factors of 12 on the top, factors of 12 on the top. Some of those were repetitive, so we got rid of them. But anyway, these are all the possibilities. Now, so this is our list, and it's, wow, what a list. I don't know how many that is. It's a lot. There's only 4 possibilities. If you look here, it's only 4 that could be maximum. We're going to choose reasonable values from the list, and so we look here and we say 1, 2, this looks like 2.5, right? I think, right? 2.5, is that what they're saying? Looks like it to me. Okay, so first of all, I guess they're choosing this half right there. Oh, no. I must not be reading the graph right. How are they setting this up? Let me look at this. They say negative 1.5. Okay, I could see that. And negative half, okay, I see that. And then 3/5. Okay, that's a good possibility. It's a little more than half, looks like. And that's almost 2. Or that's more than 2. It's more than 2. So I suppose I can see how they'd say that. Okay. All right, so looking at the graph, those are reasonable answers. And they try them. They start out here with negative 3/2. And it turns out, no good. Doesn't work. Okay, so we're on to the next one. We try negative half. And it works. Hooray. Okay, so what does that mean? It means that we're now down to, from 10 to the 4th, 10x to the 4th. I don't care about the 10, but I care about the 4. That means I'm now thinking about the remainder numbers here as 10 to the 3rd now. So if you see 10 and x to the 3rd, and negative 16 and negative 16x squared, and so forth. Okay, so, and we know that this is a factor. Remember, negative half becomes positive when I put it with the x. So that's one of my factors, but then I need to keep going. They noticed that there was an extra 2 in everything, so they factored it out. Okay, that's nice, that's smart. And then, oh, they multiplied the first factor by 2. Okay, I guess I got rid of the fraction. That's nice. Okay, that's a nice touch. Not necessary, but it's a nice touch. And then now we're going to focus on this part here, okay? So we're like, factors of the last one, that's 12. And, oh, here are the other factors of the last one. And at least now we're down to 1 on the bottom. We don't write the 1 on the bottom, because we have 5 and 5 on the bottom. So the set of possibilities is quite a bit shorter than what we had the first time. But we do have to do it again because we still have x to the 3rd. So we still need to do it one more time. And let's see. We look back up at the graph and we say, hey, 3/5 might be a good thing to try. And they skipped. They say synthetic division shows that 3/5 is a 0. So they skipped. They didn't show us all these struggles that we had before. They just tell us, hey, 3/5 works out, because I guess they're trying to save space. And so what goes with 3/5 to make negative 3? Well, 5 times 3/5. So that's my other factor. And now I'm down to x squared. And that's lovely because I can deal with that in more traditional ways. And I think I could probably factor that. And it turns out, I can't. So I have to rely on the quadratic formula. Because I can't, that looks like it could be factorable. Sure, I could come up with something. No, I have to use the quadratic. Okay, fine. So I get a couple answers that aren't, real nice whole numbers. But anyway, there they are. And so those are my real zeros. Beautiful. That's a lot of work. So let's find all the real zeros of the function. And, okay, well, let's list them out here. We're going to have factors of 3 on top. Okay? And so we're going to have 1 plus or minus 1 and plus or minus 3. And on the bottom, we're going to have factors of 48. Oh, my. So let's see. On the bottom, we're going to have 1 and 2 and 3 and 4 and not 5 but 6 and 8 and 12 and 16 and 24 and 48. Oh my, that's all on the bottom. Wow. All right, well, let's list these out. We'll say 1 over 1, that's nice. So plus or minus 1, and plus or minus 3. And then we'll say, let's see, plus or minus 1/2, because now we're over 2, and plus or minus 3 over 2. And then we'll say plus or minus 1 over 3. I don't need to do 3 over 3 because I already have 1, so I'll skip the 3 over 3. I have plus or minus 1 over 4. And I have plus or minus 3 over 4. And then I have plus or minus 1 over 6. And I will skip the 3 over 6 because I already have half. And then let's see, plus or minus 1 over 8. And plus or minus 3 over 8. And plus or minus 1 over 12. And I'll skip the 3 over 12 because I already have 1/4. I guess I'll start down here. Plus or minus 1 over 16. Plus or minus 3 over 16. Plus or minus 1 over 24. Plus or minus 3 over 24. I already have 3 over 8 somewhere. There it is. So I don't need... Did I say that right? I'm getting lost. 3 over 24 is 1 over 8. 1 over 8. I already have 1 over 8, so I don't need that. 1 over 48. Yeah. And 3 over 48 is 1 over 16, and I already have that, so I don't need to repeat myself. Those are the possibilities. Wow. Okay, so let me take a look at my graph, because I don't want to mess with all of that. I might have hoped that 1 was a factor, but it doesn't look like anything's going through 1. It looks like something close to the end there. What would you say? That might be negative 3/4, maybe? And then in here, I guess I could hope for something around 1/2, and maybe something around 1/4. So things that are close to that. I have a lot of fractions here, so wow. Let's see what I should start with. And I honestly don't know what these are. I think the easiest thing to do for me would be 1/2. So let me try 1/2. And 1/2 seems so nice. Let's hope that's it. And so it's a positive 1/2 because the root's out there on the positive side. And we have 48. And we have 4. And we have negative 20. And we have 3. Those are my coefficients. Okay. 1 negative. All right. Make sure I know if it's negative or not. I don't want to waste my time here if I'm going to go through all this. Okay, so let's see what we got. We bring down the 48. Half of 48 is 24. 24 plus 4 is 28. Half of 28 is 14. That's negative 6. You will not believe that I didn't know this, but anyway, good instincts, I guess. So that's one of my factors. Yay. And it was to the third, and so rejoice, I don't have to do that anymore. So let's see. I have x minus 1/2. Okay, because plus 1/2 goes with that. And then I have 48 x squared plus 28x minus 6. And I'm sure I can factor something out of that, at least a 2. So I'm going to factor out the 2, and I'm going to multiply it by this first part here. Maybe I'll write it in 2 steps. And I will say 2 times x minus 1/2. And I took the 2 out of the 48, so now it's 24x squared plus 14 out of the 28 there, and then minus 3. Okay, and then I can write it like this. I can say 2x minus 1. I think that looks better than the fraction. And how can I factor that second part? Well, I'm gonna do the ACB method. Here's AC. That gets me negative 72. So I'll say negative 72. Factors of negative 72 that add up to 14, right? Okay. So I think to myself, well, it's a positive 14, so negative 8 and 9, no, that adds up to a 1. I was just taking a stab in the dark. Let's see, what else could we say? We could say 18 is a factor, right? And negative 4. 18 and negative 4. That, ding, ding, ding. That's it. 18 times negative 4 is negative 72. 18 plus 4 plus negative 4 is positive 14. So I'm going to rewrite this. I'm going to say 24x squared. That's the same. And then what goes with 24? I think I'll put the negative 4 there, 4x, and positive 18x. And here's the key, that this is the same thing as this. And it is. If I add those together, I get the same thing. And that was the trick. And I hope you know that. Minus 3. Okay. So, we still have our 2x minus 1 hanging around. And out of the first two comes... What comes out of the first two? There's a 4x that comes out of both of those. Out of these two. And that leaves me behind with 6x minus... There's nothing left, so just 1. And then out of the next two comes a 3. So I have 3 times 6x minus 1. And I see that happen twice, and that's wonderful. This happens twice. So I'm going to say 2x minus 1 times, I'm going to put that 6x minus 1 right in here. And then I'm going to take my leftovers there and there. Those are my leftovers. And I'm going to make a third one, 4x plus 3. Okay, and now it's factored, and I think they want the zeros, don't they? That was the whole point. Find all the zeros of the function. Okay, last step. X is equal to, what goes with 2x to make 1, so that I can go with negative 1 to make 0? Is that confusing enough for you? I can say 2x is equal to 1. Move the 1 to the other side. Let me show exactly what I'm doing. 2x minus 1 is equal to 0. I add 1 to both sides. I have 2x equals 1. I divide both sides by 2. So x equals 1/2. That's the first answer. Then I say 6x minus 1 is equal to 0. When I solve this, I'm going to get x is equal to 1/6. And finally, 4x plus 3 is equal to 0. When does that happen? Well, it's going to be negative. And it's going to be x is equal to negative 3/4. So those are my 3 zeros that I was after. Those are my answers. And oh, what a process it was. And if I look back up at the graph, that should check out. Okay? So I forget what they are already. I think it was negative 3/4. That was an answer. And 1/2 was an answer, but it wasn't 1/4, was it? Was it 1/4? It was 1/6. So I couldn't see. So it turned out it was 1/6, okay?